Someone, can you ask your friend to join soon? We'll start at 7:05.
Okay.
So shall we start, or we have to wait if your friend is coming, or
Yes, sir, for 1 minute.
okay, okay, sure. Okay, so we can start now. Okay, I will present you my whiteboard. Okay, so can you see the whiteboard?
Yes, sir.
Okay, great. So we'll start by learning bubble sort. Okay, bubble sort. First of all, we need to know what is this sort. Okay, so when you have an array, you have some numbers in the array. Okay, 1, 2, 3, 4, 5. Okay, you must be aware of the sorting techniques, like what is sorting. Okay, what is an unsorted array, what is a assorted array. So this is a sorted array. Okay, but if I have a unsorted array, something like what I can write, I'll just choose a 5 size array. 5, 2, 1, 4, 3. Okay, so this is an unsorted array. Okay, so I need to sort this array. There are numerous techniques we can use. Okay, so one is bubble sort. So what does this bubble sort means? We'll get to know it once we know the algorithm. Okay, so what we can say, if this is possible, that in the first go, if I am able to place the biggest number at the last. Okay, so this is the last position. I'll just write down the index 0, 1, 2, 3, and 4. These are the index values of this array. Okay, I can say I. Okay, so if I'm aware of the situation that if in a single go I am able to like place the maximum element in this array at the last position, like in at this time I have 3 at the last position, but according to the sorted array I should have the greatest element of the array at the last position. So I need to place 5 at the last position. Okay, so what I can do, I can do, I can just start swapping elements. Like how we can swap elements, like just assume if this 5 is greater than this 2, then what we can do, I will move this 5 ahead and this 2 will go to the backward direction. Okay, this is the mean like motive of swapping. Okay, so what I can do, if I see that 5 is greater than the next element, so I know that 5 should be in the right position. Okay, so what I will do, I'll just swap them. Okay, so 2, 5, 1, 4, 3. I will have this array. Okay. Now again, I will search, like if 5 have a smaller element in the right side, then what I can do, I can again swap it, because in the sorted array, I know the greater element is always on the right side. So if 5 has a smaller element on the right side, I know that this 5 needs to go in the right direction. Okay, so what I can do, I can swap it with this current element. Okay, the next right element. Okay, so 2, 1, 5, 4, and 3. Okay, so I can again search for this 5. Okay, if this 5 is greater than the next element, then I will again swap it. 2, 1, 4, 5, 3. And if this 5 is again greater than the next element, so I know that this 5 needs to be in the right position. So I'll again swap it. 2, 1, 4, 5, 3. Okay, not 5 and 3. I will have 3 and 5. Okay, 3 and 5. So now I know that according to the sorted order, I have a correct element at the last position. Okay, so I know I have one position filled with the correct element. So again, what I can do, again I will perform the similar step. If this is my step 1, what I can do, I can perform the similar step again, because if I perform this similar step on this array, not on the complete array, because this element has a this position has the correct element. So I need this array to be sorted. Okay, so if I need this array to be sorted, I will perform this similar step on this smaller array. Okay, on this smaller array, what I can do, I will have 2, 1, 4, 3, and I will again start with the first element. Okay, not with the 4. Okay, what I can do, I will start just with the first element. Okay, so if I see that 2 is greater than 1, then I know 2 is needed to be in the right direction. Okay, so what I'll do, I'll just swap them. 1, 2, 4, 3. Again 2 will search, like if 2 is greater than 4, then I said no. Then 2 can be placed here, because I know 4 should be in the right direction of 2. So I won't swap. Okay, then I will search with this 4. Okay, if 4 is greater than this 3, then I know 4 should be in the right direction. So what I'll do, I'll just swap them. In this manner, I have the 4 at the correct position. Okay, like in the last position, I have placed the greatest element in this array at the last position. Okay, so I know my 4, my this position third, my position fourth is having the correct element. So what I can do, I will perform the similar step on this smaller array. Okay, so now you understand the concept. Okay, so now just understand a thing. In mathematics, you use this term concept, but in programming world, you should use the word algorithm. Okay, because what we are studying, these are some steps we need to proceed forward. Okay, which will solve our problem. So this is the algorithm. We call this as algorithm. Okay, so never use this word concept in this programming language. We should use the word algorithm. Okay, so now you can say why we have named this as bubble sort, because as in a bucket, okay, just a rough drawing. In a bucket, as we have some bubbles in the bottom, so all bubbles go upwards. Okay, you know about something like buoyancy. Okay, so as those bubbles go up forward, goes upwards. Okay, so according, uh, like similarly, the greatest element in each step go to the most rightward direction. Okay, so the greatest element, like in the step one, we have 5 and it goes to the rightmost direction. Okay. In the second step, we have 4 and it goes to the rightmost direction. Okay. In the third step, what we will have in the third step, third step, we will have 3 going to the like most rightward direction in that smaller array. Okay. So by this, we will perform the bubble sort to sort the array. Do you have any doubt till now? You can ask if you have any doubt.
No, sir.
Okay. Preeti, do you have any doubt?
No, sir.
Okay. So also, one thing must be coming in your mind, like why I'm starting with the first element only, why I'm not like watching for the fourth. Okay, and then like performing the swap operations in the rightwards direction. Okay, so why I'm not doing this? Either you can do this, but what is the most easy and convenient way is you can start from the first element itself. Okay, so okay, you must learn about, like, there is a term good programmer and bad programmer. Okay, good programmer solves things like in a most easy and convenient way, because in the like in future, whenever you are doing work on a project, so you need to work in a team. Okay, so you should like write codes which is like understandable by everyone in your team. Okay, you should not work like if you have one thing in your mind and you perform you code it like according to yourself. Okay, so now we will try to like watch learn the pseudocode. Okay, so shall I just rub it or move to the next page? Okay, so we'll see the pseudocode. Okay, in this array, what I have written, what was that? 5, 2, 1, 4, 3. I think this was the array. So what I need to do, I need to perform operations. Okay, one by one. First of all, I need to perform operation on the array of size 5. Then I need to perform the operation of size 4. Then on 3. So what I can do, I will just start with the for loop, starting with 0. Okay, and each time I need to like decrease. Okay, first of all, let's see. Let's don't understand it like this. What we'll do, first of all, we will understand like according to the swapping operations. Okay, so what I need to do, I need to swap some elements. Why? We'll start with the 0th element and we will go till end. Okay, why I have written here n minus 1? We will see. Okay, and what I need to check, I just need to check if this jth element, let's say this is the jth element, if this jth element is greater than the next element at the j plus 1 index. Okay, so this will be the j plus 1th index. Okay, so what I need to do, I will just swap them. Okay, So there is a way in C++ you can use the standard template library function, but if you are coding it in C, we will use the like temporary method. We will just save the function. We'll just save the element and then place the j plus 1th element at j part. Okay, and j plus 1th index will have the temporary, because we have filled, like I need to swap these two elements. Okay, what I can do, these are the two elements 2 and 1. This is the jth index, this is the j plus 1th index. I need to swap them. So what I have done, I have taken a variable and I have saved 2 in it. Okay, now what I can do, I will rub this, I will write 1 here, then I need to place here the previous element of jth index, so that which was saved in this temporary variable. So I will place 2 here and rub this one. Okay, so now according to this, my elements are swapped. Okay, so this is why I have written here n minus 1. Why? Because I need to swap only if the next element is smaller. Okay, and this n minus 1th element never have us like doesn't have an element in the right side. So I will just perform the swapping operations till this second last element. Okay, so I need to perform this like this. This is the step one, what we have discussed. This is the step one, and I need to perform this function again and again. So what I can do, I'll just start a loop and I will perform it. How many times should I perform it? Okay, we will see. Okay, in the first step, I know my 5 will be at correct position. In the second step, my 4 will be at correct position. In the third step, my 3 will be at correct position. In the fourth step, my 2 will be at correct position. And in the fifth step, my 1 will be at correct position. But just understand, if my these four variables are at correct position, then this fifth step is not needed. Okay, you can perform it, but this is not needed, because if my n minus will be at the correct position by itself. Okay, so yeah, what we will do, this for loop ended, and
Your
I will
voice is
save this complete. Okay, so yeah, any doubt?
no, sir. Your voice is breaking.
Okay, just a second. Can you hear me?
Yes, sir.
Okay, so did you get the point of like performing the for loop for n minus 1 times?
Sir, come again.
Sir, once explain again, sir. Your voice was breaking.
Okay, just give me a minute. So can you hear me now?
Yes, sir.
Okay, I will share my screen again. I think there might be a network issue. Okay, so can you see the whiteboard?
Sir.
Yes, sir.
Okay, did you get the point of like what I've written this?
Yes, sir.
Okay, you get it. Okay, I will just explain it in a like fastly. Okay, so in the first step, this for loop defines a step. Okay, in this first step, I know my 5 will be at the correct position. In the second step, I know my 4 will be at the correct position. In third step, I know my 3 will be at the correct position. And in the fourth step, I know my 2 will be at the correct position. And in the fifth step, I know my 1 will be at the correct position. But I am saying that this fifth step is not needed. Okay, why I'm saying this? Because in an array, if these n minus 1 elements are at the correct position, then this element will be at this position will have the correct element by itself. Okay, so I need to perform this step how many times? N minus 1. So what I'll do, I'll just use for loop starting with 0 going till n minus 1 I plus plus. Okay, so this for loop will run for n minus 1 times. Now consider what we have left till now. I need to swap those elements, but in the smaller array. After each step, I need to decrease the size of my array. So in this case, we'll just try to see. Okay, so in the first step, I know I need my j to go till n minus 2. Okay, or I can write j is less than n minus 1. But in the second step, so in the first step, I need my j to go till here. Okay, in the second step, I need my j to go till this position only. So j should be less than n minus 2. In the third step, what I need my j to go till n minus 3. So what I can do, I'll just write here n minus I, 1 minus I, n minus 1 minus I. Okay, so as I increases, this term will decrease. Okay, so by using this expression or term, you can say we have decreased the size of the array.
Sir, can you please
Okay,
repeat it?
okay, which part? This I part. Okay,
Yes.
okay. I'll just rub it and I will explain it again. I'll just explain it again. Okay, so in this array, what we have discussed earlier, that in the first go, what was that? 5, uh, 2, 1, 4, 3. In the first step, how many times I need to check for that swapping? Okay, in the first step, I was checking till this position because this position also has a right element. So I will check if this element is greater than the next element or not. Okay, so I am checking for this j less than n minus 1. Okay, so in this first step, what I was doing, I need j should be less than n minus 1 because I will go till the second last element only for checking if I need to swap or not. In the second step, what I was doing, I was decreasing the size of my array because this position has a correct element. So what I was doing, I was decreasing the size of my array and I need to perform that the previous step on this smaller array, on this smaller array. Okay, so in this time, I need my j to go till n minus 1 position for this smaller array. Now in this smaller array, what is this n? N is n minus 1 because I have left one element, so the size will decrease by 1. So my new size is n minus 1 and I will go till minus 1. In the third step, what I'll do? Okay, so this boils down to n minus 2. Okay, in the third step, similarly, what I will have j go till n minus 3. In the fourth step, I will have j just go till n minus 4. So what I can do, I can just write here n minus 1 minus I. Okay, because in the first step, I will be 0. In the first step, I will be 0. Then what I will have, j is less than n minus 1 minus I is 0, putting 0, n minus I minus 0, j is less than n minus 1. This is what I needed. In the second step, what will happen? I is equals to 1. Okay, so placing values, j will be less than n minus 1 minus and I is equals to 1. So j will be less than n minus 2. This is what I needed in the first place. Okay, So this is why I have written I at this position. Okay. So this will be the pseudo code for bubble sort. Okay. Do you guys have any doubt till now?
No, sir.
No, sir.
Okay. So we will try. Do you want me to code on this on an IDE just for a better understanding if you want?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So I will just share my screen. Okay, I will open an online IDE. Okay, can you see my screen?
Yes, sir.
Yes, sir.
Okay. So this is an online IDE. Okay, this is www.ide1.com. Okay, so what we can do, I have already chosen the language C. This is a preprocessor statement. Okay, for the compiler. Then I can use an array of 5 size, and I'll just take that example 5, 2, 1, 4, 3. Okay, so what we have discussed, we will write the bubble sort. Okay, so what we will start with, as you discuss the pseudocode, I will perform the first loop with n minus 1 times. Yeah, and the second loop will start with the 0th element. Okay, and go till n minus 1 minus I, because I need to like smaller down my array size after each step. Okay, what I'll check, I'll just check if array at I, not ith, if jth position element is greater than the next position element. So what I'll do, I'll just swap them. How will I swap? I'll just use this simple technique. Okay, m. Remember, I cannot write here array at j because I have like changed the value at jth position. Because of that, before changing, I have used that temporary variable, so I will write 10. Okay, so this was the pseudocode, and what I'll do, I'll just print the array 5. Okay, and what I'll do, I'll just print the array. Okay, I've used n here. I'll just define this. N is equals to 5. Okay, because the array is of 5 size. Okay, so what I'll do, I'll just run it. This should work fine. I don't know where does it goes. Okay, I will write it again. Okay, so first of all, I have an array. Okay, 5 size. I will take the example
Sir,
5. 2. Yeah,
what if we can give, I mean, like in that compiler, we can give the inputs, sir?
yeah. We can do that. Okay, we will write that as if we are writing it again.
Yes,
So we will write it like if we can provide the input. Okay, okay. Someone, do you want me to write it like taking the input from the compiler?
yes, sir.
Okay. So I have an array. First of all, I need to declare the array. Okay. So what I can do, I will take the input from the this input box. Okay. What I'll do, I'll take the input for 5 and I will write scanf. Okay. Because scanf is for taking the input in C language. Okay. So I'll write this scanf. what we write it here. Just let me remember what we write it here. Okay, first of all, we are taking an integer, so I will just write percentage %b, and then I need to save that integer on a variable on a memory space. So I will give the address of that space array at I. Okay, now what I can do, I'll just perform the that bubble sort pseudocode. Okay, we'll just write it here 5, because we are doing this for a 5 size array. Okay, if you want me, we can do it like for this n size array. We'll also take this n as input from the programmer. Okay, okay, so I'll just write it here n. So yeah, now we can start. This loop will work for n minus 1 times. Now this loop will start from the 0th element and go till end n minus 1 minus ith, as we have discussed, because we need to like smaller down my array as we go ahead, and we will check if array at jth is greater, the jth element is greater than the next element, so I need to swap them. Okay, I'll just take them as in, save the jth element in a temporary variable. Okay, now this should work fine. Okay, we have done this loop for n minus 1 times. We have used this loop like on the smaller array as we go ahead, and after this I'll just print my array. Okay, this is how we print our array. Okay, now this should work fine. I'll just take down an input. First of all, 5 size array, 5, 2, 1, 4, and 3. Okay, so this should work fine according to me. We'll see. If we get an error, we'll try to fix it. So yeah, this is working fine. I get my array as in sorted order 1, 2, 3, 4, 5. Okay, do you have any doubt in this code?
No, sir.
Okay, and Preeti?
No, sir.
Okay, so this is how we perform the bubble sort, and now you know why we have named it a bubble sort. Now we will discuss about the time complexity of this bubble sort. Okay, I'll just, okay, here's my pen. So I'll just use the next page. Okay, so we will understand the time complexity of this bubble sort. In this array, okay, of n size, we will consider this array of n size n. Okay, so what I'm saying, what is time complexity? You all know, you both of you know that what is time complexity. Okay, so we will understand what is the time complexity of this bubble sort. First of all, in the step, in the what were the steps that I am swapping? Okay, in this swapping, this swap takes in O1 time, big O of 1 time. Okay, but we are performing this swapping operations over this complete array. Okay, so I'm checking for n minus 1 elements in the first time. Look, we have used 2 for loops. Okay, we have used these 2 for loops, and this one runs for n minus 1 minus I times. Okay, we'll see. When I is equals to 0, this for loop runs for n minus 1 times. When I is equals to 1, this for loop runs for n minus 2 times. Not n minus 2 times, n minus, or works on n minus 2 positions. Okay, when I is equals to 2, this works on n minus 3 positions. Okay, this will go till I is equals to n minus 2. So what will be the part? N minus 1 minus n minus 2. Okay, and it will be n minus 1 minus n plus 2. Okay, I'll cut it. So yeah, it is 1. So what you can see, I'll just sum it up. Okay, for time complexity, I'll just sum all of this because this is what we are performing functions, performing some operations on my array. So what I'll do, I'll just sum these terms to get the complete time complexity. Do you have any doubt like why we are summing it up?
Yes, sir.
So you can ask if you have any doubt like why we are summing it up.
Yes, sir. Why we are summing it?
Okay. So do you know about time complexity of a approach or of a function or of the code what we are writing?
No, sir. Actually, this is a really new concept.
Okay, okay. So you should stop me at that point because now we'll talk about what is time complexity. Okay. First of all, what I'll do, okay, I will get back to this page after we understand what is this time complexity. Okay. So time complexity. Okay. So look, what we are doing in programming, in programming, we are commanding my computer to do a to perform a function to perform a work for me. Okay. Now there are numerous ways to perform a function. Like if I want like a water of glass, either you can pass it or you can ask your mom to pass it. You can ask your complete family to like serve it one by one, and then it will come to me. This increase the time. Okay. If I ask my mother to pass fetch me a glass of water, she can direct. Okay, this is me. Okay, this is my mother. If I ask her to fetch me a glass of water, she can directly fetch me. Okay. Or if she asks my sister, like she will fetch to her and then she will give me. And she will also, if she can also add a person, this will increase the time. Okay. So in this way, you can understand like any function is possible with different time complexities. Okay. What is this time complexities mean? Because just understand if you want to perform an approach, there are number of ways. Okay, number of ways. So how will you define that this number of ways good? This first one is good, but this second one is not good. Both of them are performing the same work what you want to do. Okay, you want to sort the array. You want to sort the array, but there are different techniques. Now you should be able to differ between them. Like the bubble sort is nice, but selection sort is not nice. Selection sort is also like a sorting algorithm. Okay. Now these both of these are a sorting algorithms. Now you need to differ between them. Like bubble sort is great, but selection sort is not great. How we will differ? We will differ. We will differ by time. Okay. How much time this bubble sort take? Look, if bubble sort takes 1 second to perform to sort the array, and if this selection sort takes 10 seconds to sort the array, then what will you say? That this bubble sort is great. You want to save time. Okay. Now we know this if this bubble sort is great and this selection sort is not great on the basis of time. Okay, so you cannot know the time that the compiler takes to compile and execute your code. Now you can differ that time by looking at the approach of each these functions. Okay, in this bubble sort, we know the pseudocode. Okay, this was the pseudocode. This was the pseudocode for the bubble sort. Okay, but how can you measure time by watching this pseudocode? Okay, we will understand something like if I want to swap these two elements, here is one, here is two. If I want to swap these two elements, I'm just using a temporary variable. Okay, I will save here one, and then I will place two here, then I will place one here. Okay, this can be considered as an O1 time. What is this O1 time? This is constant amount of time. Okay, It can be 1 second, or this will be in milliseconds. We consider it as constant time. But if we are performing the swap operations on n elements, if we are performing the swap operation on n elements, then what I can say, I am performing n times the single swap operation, and that single swap operation is completed in O1 time. O1, what this O1 time means? The constant time. Now I can say the complete swap operation on n elements take big O of n time. What is this O? Okay, so this is your homework. Just understand what is big O notation, what is omega notation. Okay, why we are writing this big O here. Okay, I'll just give you a hint. This big O stands for like worst or the average case. Okay, worst case time complexity. Okay, you'll get to know once you start solving problems. You will get to know like there are some worst cases, there are some average cases, and there are also some best cases. So now you know if you're performing the swap operation on n elements, this will take big O of n time. Okay, this is just for the knowledge of the programmer that he can differ which function, like which approach is great, okay, and which approach is not great. So someone has introduced in the programming world a time complexity. Now by time complexity, we can differ like bubble sort is great or not. Okay, so did you get it like what I said till now?
Yes, sir.
Yes, sir.
Okay, so now we know about the time complexity. There is also something called as space complexity. There is also something called as space complexity. Now you have two programs. First program number 1 and program number 2. Okay. Now you know both of them take equal time complexities. Okay. So time complexity of one is equals to time complexity of second program. Now how can you differ? Now someone has introduced one more thing, that we can differ them by space complexity. Okay. So you know like in a computer many functions are working at the same time. Okay, and the memory which we have in a computer will be used at each and every seconds. Okay, so just understand, if you have two programs, program number 1 and program number 2, you have this much space of memory available. Okay, so if this program 1 takes this much amount of memory, just say 1/4. Okay, the program 1 takes only 1/4 amount of memory of your computer, and your program 2 takes 3/4 amount of memory of your computer, program 2. So what you can say, that this program 1 is great because now you have this much memory available, so for your other functions to work, your operating system, okay, your all functions which are working in the background can take this memory which is available. But in this computer, this program 2 is taking the 3/4 amount of memory, so I have only 1/4 memory left for other functions which can take. Okay, so according to this space complexity, we know that this program 1 is great, this program 2 is not so great. Okay, and how can we measure the space complexity? Look, we have again considered something as constant space. If I take a variable integer x is equals to 10, now this x takes the space in the memory. Okay, look, whenever you want to like count something, then you need to give something like a basic term, like what you give like 1 gram. Okay, 1 gram is the most basic term. Then what you can do, you can measure something in 1 kg or like in quintal, okay, in tons. Okay, so you have given 1 gram a thing, like this much is 1 gram. Okay, so this that similarly we have given a space as big of 1. This is a constant space. We have considered this a single variable space as a constant space. Okay, so in an array of n size, we have n positions. Okay, if we have n positions, so we can say we have taken n spaces of constant space. So what I can write, I have taken big O of n space. This is the space what I have taken in my memory. Look, whenever you want to calculate something, so you need to give something a basic understanding, and on that basic understanding you will count other things. Okay, if this pile is considered as 1, then now you can say that these are 2 piles, these are 3, these are 4, these are 5. Okay, so yeah, similarly we have considered a variable space in a memory as constant space. So an array will take big of n space in the memory. Okay, is this clear till now?
Yes, sir.
Okay,
Yes, sir.
now we know what is space complexity, what is time complexity. Now we'll get back to the bubble sort. Where was that? If I can see. Acha, this is undo previous. Okay, just now understand, we are performing this swap operations. Okay, this is a single swap operation. Okay, so what I can write, I can write this swap operation works in constant amount of time. This is clear to me. I'll just rub the space. I need space to write. Okay, now this swap operation, a single swap operation, take constant amount of time. Okay, and I am performing this swap operation how many times? In this for loop, I can say that then when this I is equals to 0, then I'm performing this swap operation starting with j is equals to 0 going till n minus 1. Okay, so how much is this? N minus 1 time. This is n minus 1 time. So I'm performing the swap operation when I is equals to 0 n minus 1 times. Is it clear?
Yes.
Okay, I'll just explain it again. Your voice is not something like it is clear or not. Okay, so I'll just explain it again. Look, this swap operation takes big of 1 time. What is this? This is a constant amount of time. Now, how many times we are performing this swap operations in my complete bubble sort, in the complete bubble sort, will define the time complexity of this approach. Okay, this is clear to me. Like if I'm performing this swap operation 10 times, then I know the time complexity of this bubble sort will be big of 10. 10 times big of 1. Okay, so now I'm finding how many times I'm performing this swap operation. Or if I'm not performing, even if I'm checking like if I need to swap or not, that will be also considered. Okay, so I'll just check this swap operation on the first large array will be checked how many times. Starting from 0, j will start from 0 going till n minus 1. Okay, so I've checked this condition n minus 1 times in the first part. Now my array will be smaller, and how many of n minus 1 size? Okay, of n minus 1 size. Now I will check the jth position starting from 0 going till n minus 2. Now how many times I have checked this condition? N minus 2 times. In the third part, how many times I will check this condition? N minus 3 times. Okay, in the end, I can say n minus 1 at time or n at time, n minus 1 at time. I will check for just one. Okay, why I'm writing here 1? I have 3 and minus 3. Okay, and I am going Okay, we have started from 1. Where till I go? I will go till n. I'll just write it here again. I have started with the first step, second, and then third. I will go till n minus, okay, only n, because I have started from 0 here, going till n minus 2. Okay, I is less than equals to n minus 2, and I have written here 1, so I'll just add 1 at the last part. So here it will be n minus 1. Okay, so for the first part, I am checking this condition n minus 1 times. For the second, I am checking this condition n minus 2 times. Third, I am checking the condition n minus 3 times. So for n minus 1th time, I will check this condition for n minus 1, n minus 1th time. It will be 1. So I am checking this condition n minus 1 times plus n minus 2 times plus n minus 3 times plus plus 1. This is why I am adding to get the final time complexity. And what will be the final time complexity? Number of times checking this condition, multiply big of 1, because I know this swapping operation takes big of 1 time. Okay. Also just consider, if I'm checking a condition, so compiler will take some time now in running. If I'm checking like 2 is greater than 3 or smaller than 3, this will take some time. So we have considered that time also a constant amount of time. Okay, so this is why I'm adding this all. Okay, did you get this?
Yes, sir.
Yes, sir.
Okay, so this is why I'm adding. Now what I'll do, I'll just add all these to find that final time complexities. So we'll see, I need to add n minus 1 plus n minus 2 plus n minus 3 going till 1. So what I can say, what I can write it as n minus 1. Okay, so what I will write n plus n from all. How many times I am writing this? N minus 1 times. Okay, so what I can write it as n multiply n minus 1, because starting with 1, 2, 3 going till n minus 1, I know I have n minus 1 number of brackets, and in each bracket I have to add this n. So what I will do, I'll just write n star n minus 1 plus minus 1 minus 2 minus 3 going till minus n minus 1. So what I can do, I will just take this minus 1 plus 2 plus 3 plus 4 going till n minus 1. So I know this is my final equation. I'll just find n star will be n square minus n minus, now sum of n minus 1 elements, you know. So sum of n consecutive elements starting from 1 is n into n plus 1 by 2. Now if I have n minus 1 elements, so it will be n minus 1 star n by 2. I will just find the final answer, n square minus n minus, so this will be n square minus n by 2. So it will boil down to n square minus n by 2. This is our final time complexity. Now watch. I'll just rub it, and I have this is my answer, n square minus n by 2. Okay, now I know my final time complexity will be n square minus n by 2. N square minus n by 2. So I can write it like this. Okay, so just understand this. I won't write this as this expression. I know if someone has a time complexity of n square, and if a function has a time complexity big of n, So I know this n square is greater than this big O of n. So what I'll do, I'll just omit this. Why I'm omitting this? Look, in this big O of n square minus n by 2, we write it as like big O of n square. Why we write it like this? Because I know when in the programming world, when we are working on a data, that data is a very large data, like really, really very large. So n can be like nearly equals to 10 raised to power 10. So what will be n by 2? N by 2 will be something like 5 into 10 raised to power 5, 9. Okay, so can we say like n is equals to n by 2? Okay, so this is why what I have written this, like just write it here. I'll just write here n square as 10 raised to power 10 minus 10 raised to power 10 divided by 2. Okay, we will see what it comes. Big of 10 raised to power 20 minus 10 raised to power 10 by 2. So can I say that this 10 raised to power 20 is really, really very large than this 10 raised to power 10? Okay, 10 raised to power 20 minus 10 raised to power 10 is nearly equals to 10 raised to power 20. Can I write it like this? So similarly, what I am writing this expression as big of n square. Okay, because if this is possible, then we can write this expression as this. Now, is it clear to you like why I'm writing O of big O of n square minus n by 2 as big O of n square only?
Yes, sir.
Okay. So yeah, this is just the bubble sort today we have discussed. I have thought like we can discuss more, but time's up. If you have any doubt till now in the bubble sort, just ask.
No, sir. It's clear.
Now, is this clear to you like what is time complexity versus space complexity? Why I'm writing n square minus n by 2 as only n square?
Yes, sir.
Okay. So you should always focus on calculating the time complexities. Okay. Because then only you can differ like which program is good and which is bad. So yeah, that's it for today. If you guys have any doubt, you can ask or you can start leaving. Okay, so thank you guys for attending this class.